Hey everyone, it's Mr. Canfield. This is the Geometry Chapter 2 review. So I'm going to spend some time in this packet, not as much time as normal though. So I'm going to do a few problems out of this, and then I have a couple extra things to do. These are going to come back when I talk about proofs in a little bit. So first two questions, it's really important that you understand are these two. And I've got my calculator already handy, which is good. So let's say I'm asked to solve for x in a situation like this. Well, one of the first things we'll do is we can find different missing angles. So I've got 39, I've got 94. Well then, to find our third one, we could take 180 minus 39 minus 94. I mean, you could also do 39 plus 94 and then take 180 and subtract it from it. It doesn't matter. Either way, you get 47. So I know this angle here is 47. And if I want to find out what this other angle is, there's a couple ways we could do it. And generally, what I like to say is if we can figure out what number this is supposed to be, that kind of makes things easier. So if I do 180 minus 47, I get 133. So I know that 4x plus 1 is supposed to be 133 degrees. Now, solving this takes algebra, but we've done the geometry to find that. And there is also that little extra thing of where these two angles are going to add up to this external angle. These do add up to 133, which we saw earlier, but if you're going to see that, you're going to see that. You don't need me to tell you that. So to solve this, I'll just use regular solving moves. I'll subtract 1 from both sides. I'll get 4x is equal to 132. Divide both sides by 4. So 132 divided by 4. I get 33. The end. Okay. So let's look at number 5 now. So number 5, we have a lot going on here. And when you have a lot going on, it helps just to focus on little individual pieces. And is there anything that I notice, anything that I can do? So maybe we start here, we look at this. I see maybe like this and the x are corresponding angles. So they're going to be congruent, but I don't know what either of them are. I don't know anything about these angles or these angles down here. What we can see though right here is I have this straight line. I have a linear pair here between the x and the 210 minus 2x. So x plus 210 minus 2x, if I add those up, I should get 180. And this is one of the big separation points. Am I saying that I can add them up to get 180, or are they going to equal each other, or is something else going on? And generally, it's going to be one of the first two. Either going to add up to 180 or they're going to equal each other. So now that we're here, one of the dangerous moves that I see a lot from students is they'll try to add 2x here and here. But just a reminder, if you're adding 2x here, that cancels it. You're doing this on one side of the equal sign. So if you add 2x over here, you would need to add 2x over here as well. So what I think you're trying to do is combine the x and the negative 2x. So if we're doing that, we have a single x here, we have a negative 2x here. We're doing 1 minus 2. We don't have to do any fancy, we're just combining like terms. And so there's negative 1, x is left over here. There's still the 210. And then there's 180. So now if I continue to solve this as normal, I'll subtract the 210 from both sides. 180 minus 210, I get negative 30. So negative 1x is equal to negative 30. Divide both sides by negative 1. I get x is equal to 30. Okay, so I know x is 30. So I could even come over here and I could write 30 right there. Well, hey, sorry for the constant readjusting camera. So that means that this and this, these are congruent to each other because they're corresponding angles. So I could just say y plus 25. Does that show up on the camera? It does, okay. Equals 30. And then subtract the 25 from both sides to get y is equal to 5. So that's where we get those from. Yeah, two really good questions for us to look at. All right, slope. I'm gonna do my full slope suite right now. We'll talk all about it. We'll talk about these slope questions and then the one on the back. So the main thing for slope that we talked about was counting. Sorry for the slurp, excuse me. Okay. We're gonna do rise over run. And the reason that it's called rise over run is it's slope is another way of talking about our vertical change over our horizontal change. There's a formula to use that you can calculate slope between 2 points, and the formula really does just take the vertical change and divide it by the horizontal change. So for this first line I have here, I find a dot, and you find any other dot on that line. I happen to see one right here. That's pretty nice. But let's say you don't see that, and you don't see one, oh, I didn't see one until all the way down here. So you could start here, or you could start here. It will not matter as long as you're careful and track your pluses and minuses correctly. If I start here, I'm gonna count this way differently than I normally do. I'm gonna count over first. 1, 2, 3, 4 over. I went to the right, so that's a positive 4. And then 1, 2, 3, 4, 5, 6, 7, 8. I went 8 down. The slope of this line, I need to make sure I do vertical over horizontal. So the up and down, the -8 goes on top, the horizontal, the 4 goes on the bottom. If you don't know this little trick, oh, never mind, it's just -2. The calculator can simplify fractions for you. Desmos is even better for that, but this one, if you push the math button, the very first option, little arrow frac, you click that, if it's not already a simplified number, it'll do a simplified fraction for you. Okay, so these ones in the middle here, okay, I said I was gonna do them, all right. I just don't wanna get this too crowded with different colors and stuff, and I didn't bring an extra over. Let's see, I see a crossing here, and then I see a crossing here. I'm gonna count this one differently than I would normally do as well. I'll start here. I'll go 1, 2, 3 down. That's -3. And then 1, 2. I went left, so that's -2. So that's this line here. What's a -3 over a -2? It's a positive. And I can do that math, enter, and turn it into, it's 3 over 2. All right, I'll do the next one in orange. That's French for orange. You have to say it with attitude, otherwise it doesn't count as French. So I see a dot here, I see a dot here, I see a dot here. Pick any two, you count between them, it doesn't matter. It's the dots that are crossing on the lattice points of the grid. So like here, I can see 1, 2, 3, 4. I went up 4, and I went over 1. This is how I usually start at the left and go to the right. That's generally how I do it. And I get 4 over 1. Oh, that's cute. I wrote a 4 there earlier for a different problem. So here I get 4. You can write 4 over 1. You can write 4. There we go. Oh, it's off the screen. It's on the screen. So, oh, this -2 earlier, you could have written -2 over 1. That's totally fine. Okay. All right. So, What did I do these last two? These last two look parallel. That's going to be a great segue into us talking about parallel and perpendicular. So they look parallel, are they? Well, let me see. This one, I can see a crossing there and the origin. So I can go up to 1, 2, 3 over 3. So this line, I got my slope is 2/3. And then this last one here, I'm going to keep using red because I think it's going to be parallel to that. I know it isn't, but just like humor me. So I see this one here, I see this one here, up 1 over 2. Okay. Do these slopes perfectly match? No, they're not the same number. They're not parallel. The only way for two slopes to be parallel, for two lines to be parallel, is if they have the exact same slope. So failure. This one's 3 over 2, that one's 2 over 3, that's nothing either. So exact same slope is parallel. And perpendicular is when we have the same numbers, but they're flipped and one's positive and one's negative. So I have -2 over 1 and I have 1 over 2. These are the same numbers, they're just flipped, and one's positive and one's negative. The fancy terms for these are opposite, that's the one being positive, one being negative, and reciprocal, that's the flips of each other. So that means that they are perpendicular. Yay. Okay. So let me recap my markers. One danger of using multiple colors is if you use a lot of them and you don't put the caps back on, then markers dry out. Sad day. Okay, that's gonna lead us over to this last question here. If the slope of AD is -3/4 and the slope of CB is 2/3, how are the lines AD and CB parallel, perpendicular, or neither? Or sorry, are they, and how do you know? Well, are these the exact same slope? That's -3/4. Is this -3/4? No. So they are not parallel because they must be exactly the same. What would perpendicular to -3/4 be? Well, it'd be the 3 and the 4, but flipped, 4 over 3. And since that's negative, its perpendicular would not be negative. That's not 4 over 3. What would the perpendicular for this one look like? Well, you'd take the 2 and the 3 and you flip them, and then you throw a negative on it since there wasn't a negative. And we talked about it in class a while ago. That negative could go up here, down here, out front. As long as there's a single negative, the whole thing's negative. One bad apple spoils the whole bunch. All right, so that is the end of what I'm going to talk about here on this packet. 7 and 8 you don't need to know how to do, and okay, fine. Number 9, real quick. So it says AEB is 7y minus 3, CED 87 minus 2y. Well, hey, look, we got a pair of vertical angles here. These are congruent to each other. So you can say 7y minus 3 is equal to 87 minus 2y. So now you just solve this. This is the hardest algebra we're going to see on the test. He said, looking at his paper, double checking. Yeah, I have the test right next to me. It's over here. You can't see it, but yeah, cool. So, I got y on both sides. So now I can do the thing like where I do plus 2y. I can do the opposite of that. I can do it on one side of the equals, and I'll do it on the other side as well. Same thing both times. You do that, you get 7 plus 2 is 9. 9y minus 3 equals 87. Then we can add the 3 to both sides and get 9y is equal to 90. Divide both sides by 9 and get y is equal to 10. So if y is 10, it says find all the angles in the diagram. Okay, so I can take that 10 and I can plug it in here. and you get like that number. So that'll be this angle. And hey, they're vertical angles. They're equal to each other. So that means this is also 67. But hey, if you don't trust yourself, you plug it in. If you plug it into both, you should get the same number both times because they're supposed to be equal to each other. That's all the stuff we've done. Well, we can find this angle now. We just need to do 180 minus 67. 113. So this is 113, and hey, this is 113 too. I'm bummed. So I wanted you to be able to find every angle, but we don't. It says find every angle in the diagram. The problem is like this angle here and this one here. We don't have the tools yet to find those. There's a way to find them using trigonometry, but you don't know what that is yet. So we're done. Okay. Things we did not talk about in class that you should know how to do. Let's look at this puzzle. I wanted to give you something a little extra for the review, for at-home review. Oh, I didn't think about supplying you a copy of this. I'm sorry. Excuse me. Okay, well, let's say we see this problem, and there's lots of unknowns. The way that I'm going to handle this is I'm going to just see what I can figure out. You can start in so many different places. So if you're interested in trying this problem, what I'm going to do is I'll put a PDF on Schoology. But if you don't feel like doing that, you could screenshot this. Like if you're on your phone, you just screenshot it and zoom around and try filling things out. See how much you can fill out. I will I'm gonna go ahead and start doing it. I made this puzzle, that's why it's got the poor handwriting in it. And I see a couple different places I could start. I see the 62 here and I see the 28 here. And both of those I'm like, ooh, that's easy. Because like the 62, I can go 62, 62. And then I could find this just by doing 180 minus 62. So that's 118. That's 118. I'm just going to find angles even if they don't have a letter next to them. I'm going to see how much I can find. Oh, now, hey, look, these are parallel lines, and this is a transversal. So it looks like it's a broken transversal, but so then I could say that that 118 transports down here. This is 118. That 62 won't work here because of the weird corner, but this is 62. And hey, look, this has a congruency marking, a weird looking one, but it's the same one there and there, so that's 62 as well. Oh, hey, look, K has a, why does K have a, that means K is 90. Why did I do that? Well, let's see if this is true. 28 plus 62 gets 90. We take that away from 180, and sure enough, we get 90. Yeah, that is a 90-degree angle. That's weird that I did that. All right, whatever. So that's 28. That means that this here is 28. All I'm doing is I'm just following my numbers. I'm chasing where they lead me, and I'm just seeing what I can do next. Oh, I have a linear pair here. Oh, these were vertical angles. That's why we said that. Linear pair here. So 180 minus 28. 152. Okay, 152. Cool. Now what? Oh, well, I see we have these two sets of parallel lines. So like here I've got two parallel lines cut by a transversal. So I can copy paste these over here, right? This is 28, 28, 152. This whole thing here is 152. So what would that mean if these are two equal pieces that add up to 152? Well, I can take 152 divided by 2 and get 76. On the real test, if there's something like this, hint, and you get a decimal here, that's fine. Okay. So guess what? E is 76. Okay, let's see. What's next? Oh, wait. I've got two parallel lines and there's a transversal. So I can take these angles and copy paste them down here. So these are 28s again. And then that's 152 and that's 152. Okay. Cool. There's some weird stuff over here. We'll talk about that one in a minute. That's, oh, I wish I had, that's not on the test. I wish it was. It's a fun thing. There's a bad congruence ring. This is supposed to say that these two things are congruent to each other. It says this is 166. Oh, wait, I missed this right here. We got our 152s again. And then our 28s. You know what? I actually could. All right. Okay. Slow your roll, Canfield. I'll come back to those. All right. So 166 down here. If I do 180 minus 166, that'll give me this right here. That's a 14-degree angle, and this has a congruency marking down here. So, and we knew that because it's a straight angle. 14. So this is 14. Cool. Okay. So our last little one is this little tricky thing here, and that's a weird little, but like hopefully you can see I put the same symbol on all three. That means that all three are the same. Well, if all three are the same, what's 180 divided by 3? It's 60. So this is 60, this is 60, this is 60. And since these are two parallel lines, here's a transversal, so that's 60. That means that this is 60, and same argument here, this is also 60. So that would make these 120, and I solved all the angles except for this one over here. So I will, let's see. Well, if I know the whole way around this, well, no, hold on. This is 62. Oh, you know what? I think that means that this is an impossible figure. Because if we add all these up, let's see, 118 plus 62 plus 62 plus, oh wait, that's it. We got all that, and then we got 360. This is also equal to 118. So my diagram is illegal. The numbers I picked aren't real, but you didn't see that. All right. Well, hey, hope that was a interesting little endeavor. And hopefully you see it's not as hard as it might seem at first. You just start in one place and you see where it takes you. Jump around if you need to. All right, I'm going to do 2 proofs. Okay. And I don't have the answers to these. I don't remember what they are. So I'm going to have to find X first, and then I'm going to turn it into a proof. Because I wanted to give you something extra if you are bothering to watch the review video. This is here for you. So one of these might be what our proof looks like. All right. So we got bam, bam, these. So let's look here. Are these equal to each other, or are they supplementary? Like that's our kind of first thing to do. So if I highlight those and then highlight these, that's because it's always how it works. Well, one of these got the purple one and one of these got the green one. So they're not in the same area. They're not going to be the same number. And so what that means is I can say that 2x plus 7 plus 3x minus 2 is equal to 180. Let's contrast that with this down here. In this one, these are what we call alternate interior angles. And so in this one, we can say 2x plus 7 is equal to 3x minus 2. So if I'm going to, prove, well, hold on. What I would do if I was going to give this to you on a test is I would actually tell you what x equals. So let me find out what x equals real quick. 5x plus 5 is equal to 180. We'll subtract the 5x is equal to 175. Then I'll do, right? We know 2 plus 3. 7 minus 2 is 5. It's just sometimes it's good to just double check. 180 minus, why am I doing that one? Divided by 5. 35, okay. So if this was a proof, I would say prove x is equal to 35. I don't need to redo this part. We'll talk about what to do there in a minute. Because these two proofs would be very similar. I wouldn't give you both of these. And then on this one, if I'm solving this one, so I'm assuming if you need help solving this, I would recommend always take the x on the right-hand side and move it over. That is not always easier, but if you're anxious about it, it always works. So now we have a -2 left over. 2 minus 3 is -1. So we have -1x plus 7. And then I'll subtract the 7 from both sides. I get -1x is equal to -2 minus 7, -9. And then I'll divide by -1. I get x is equal to 9. So we've done all the calculations. This problem, if it was a proof, would say prove x is equal to 9. This one would say prove x is equal to 35. So now let's talk about proving them. This one's easier to prove, so I will start with this one. I'm trying to figure out what color to pick. That's the other thing. You get decision paralysis when you have too many colors to pick from. There's too many fun options. So if I was going to prove this, I'm going to put a star here. I haven't written any of this yet. I would say, since the lines are parallel, I see the little markings that show they're parallel. That's how we were able to say these are alternate interior angles. Another way to write that, like if there was an M and an N, we would say since M is parallel to N, I don't have labels on these, so I might need to, it's the kind of thing where you could like add in 1, 2, 3, 4 kind of thing. But you could, with this one, you could say 2x plus 7 is equal to 3x minus 2 by alternate interior angles. And let's talk about the point breakdown here. You're giving a prerequisite. We needed this. We're making a truth claim. And then we have the reason for that claim being true. The thing is, alternate interior angles without the lines being parallel doesn't mean anything. That's why I needed all three of these pieces. So since this and this, boom. And here's where I would go to the star. I would do the star stuff now. And I'd say by algebra, x equals 9. And we're done. Let's say you do the algebra and you don't get 9. And you can't figure out what you did wrong. Well, then you could say something like, which disproves that x equals 9. And I can tell you the one that I would give you on the test does work, but to give yourself, full points essentially, so there's probably a baby mistake in your algebra somewhere, you're not getting 9, and you're saying, but all these things say that this is supposed to be equal and blah, blah, blah. So that means that x isn't 9, x is what I got instead. So, that's our simpler proof. Here's our slightly more complex proof. We need to figure out a way to say that these are supplementary. So in this case, I might throw a little 1 in here and say that's angle 1. Because now I can say, oh yeah, and we'll call this M and N, like they'll be labeled for you. Since M is parallel to N, 2x plus 7 is equal to angle 1 by alternate interior angles, which is, yeah, that's what I wrote a minute ago. So alternate interior angles, okay, so we know that. And then also angle 1 is equal to, whoops, nope, angle 1 is not equal to that. I was gonna say these are vertical angles, they're not. Had I done that, I could say that. But I could say that also angle 1 plus 3x minus 2 has to equal 180 by linear pair. Well, hey, angle 1, that's also angle 1. So I can replace the angle 1 with this. So by substitution, 2x plus 7 plus 3x minus 2 equals 180. And then you don't need to write by algebra. So x equals 35 bucks. Because it's fun to write the little bucks. Okay. So to reiterate, proof is not what's going to make you sink or swim. There is one proof question. If you were to skip it completely, you can still get a B on this. Like, it's not going to ruin you. Okay, I think I've talked about everything I need to talk about. So I hope this video was helpful. I know it was a little bit longer than the previous one. Also, I have done a ton of major hints here. Like this page, I hope this was helpful me talking through. I mean, if it's not, reach out, please. And this thing, this is what the test question used to be. I've changed it now, but yeah. So you guys are great. Hope you're doing well. Hope you have a good day. Yeah. Oh, shoot. How do you... Oh, bye.